So this week, just want to give a quick overview of FME, what it is, for those who aren't familiar, and then Tim from Ponderosa is going to present how they're using FME in their system today. So what is FME? It was developed by Safe Software, which is out of Canada, in 1993. It's known as Data Transformation Technology. FME originally stood for Feature Manipulation Engine, but now they just call it FME, dropping the formal name of it. And what it's for is to get data when, where, and how you need it from one source into another. So some of the key capabilities of FME is it converts from whatever the source data is. We'll convert it from the format, it will transform it, and it will integrate multiple unique features together if you want them to, and it will share the data, and then it will validate the transformation throughout the process. There's two basic versions of FME, the desktop, which has professional Esri database, and then we have developed special plugins for GE and Oracle. And desktop is standalone. You create your workbenches in it, and then once you create your workbench, you can kick it off manually to do it, either a one-time conversion or you can click it as many times as you need to do it. Then there's the FME server, which I can take my workbench from my desktop, put it on the server, and then I can batch it and do scheduled transformations when and where I need it. And then different users in the organization can go in the server and say, oh, that's the data I want to transfer at this time, and they can pick all the workbenches are available throughout the server using the GUI. And SAFE has just recently come out with the FME Cloud, where if you have a one-time data translation and you don't want to buy the software, they have FME in the cloud where you can send your data, do your migration, and bring it back again, and they charge by the action on that one. So at this point, I'm going to turn it over to Tim, who's going to give an example of how they're using FME, and I believe, Tim, you presented this actually at the SAFE conference, if I'm not mistaken.
Okay, well, good morning, and just want to thank you all for attending today to talk a little bit more about FME. And I'm going to be talking to you about FME, spatial querying, and a CAD-driven GIS. And what does that mean exactly? Well, hopefully by the end of this next 30 minutes, I will be able to answer that. Just a little bit about myself. My name is Tim Jones, and I'm going to be talking to you today a little bit about our organization, Ponderosa Telephone, how we're using GIS, and specifically how FME has been a tremendous benefit to our GIS solution. So just a real quick bit about myself. I've been doing GIS since 2006, where I started out as an applications engineer for an Autodesk reseller supporting civil and geospatial software. I completed my degree in GIS in 2007, and later that year came to work at Ponderosa as the GIS supervisor. So for about 7 years now, I've managed Ponderosa's GIS, and I've seen it grow from a simple engineering tool used primarily for planning and engineering to now an enterprise solution providing information critical not only to engineering but also operations, marketing, regulatory, customer service, and field operations. Talk a little bit about Ponderosa itself. We're an independent telephone company in California offering phone, data, and cable TV to approximately 10,000 subscribers. This map shows all the independent, actually all the telephone companies throughout California, and we're this kind of maroon color here and there. So we cover about 1,700 square miles in the central Sierra Nevada, just outside of Fresno. We're situated between Yosemite and Sequoia National Parks. Although we don't serve those parks, we're right in between them, so it's a beautiful area. In addition, we also have a nice large exchange down in the Mojave Desert, 2,300 square miles, where we serve a grand total of 73 customers. But as you can see, we serve a wide range of geography from up to 10,000 feet in elevation in the granite peaks of the Sierra Nevada to sea level, as well as the high desert regions of the Mojave Desert. And needless to say, this presents a wide variety of challenges for building and maintaining our network, which includes over 2,000 miles of copper and 460 miles of buried fiber, as well as 30 radio links across rugged terrain. I always like to show people our office. This is where I work, and when we're out in the field, it's a very nice area, and I feel very privileged to be able to work in this part of the state. And, we have a lot of wildlife as well. This is one of our desert tortoises that we run into in the Mojave area. These are an endangered species, and you have to be kind of careful with these guys because if you get too close to them, they will dehydrate themselves rather quickly, just basically out of fear, if you know what I mean. And so you actually have to be tortoise certified to work in this area. Otherwise, if you scare these guys, you could cause damage. So you're all aware, I am tortoise certified, so we're good to go there. So a little history about our GIS at Ponderosa. As you can see, it's somewhat of a recent development, starting back, I guess, about 10 years ago or so. And as I mentioned earlier, it started out as a simple planning tool for engineering, but has since grown from needs for a wide variety of departments. So today, for example, marketing uses our GIS to print mailers to potential subscribers, overlaying predefined project areas on our county parcel data. Locators use tablets with our mapping data in the field to help them find and mark underground facilities for underground service alerts. Customer care accesses our GIS for loop length qualifications to determine what services are available for each customer. And recently, new regulatory requirements have relied heavily on our GIS for reporting purposes, as broadband mapping is now a requirement for the CPUC, by the CPUC. So what are the components of our GIS? How is the construction? Well, until recently, prior to FME, this is what our GIS looked like, and basically we were a tile-based, we had basically tiled DWG maps using Map 3D with data stored in SQL, and the data was associated to each point, block, polyline, polygon for attributes for each feature, such as copper, fiber, poles, pedestals, manholes. And we used Oasis FM was our front end, a third-party telco data structure, which provides tools for manipulating the data outside of CAD as for functions such as cable assignment, splicing, cross-connecting, and tracing. But as you can see here, since we do start and finish in AutoCAD Map 3D, we have somewhat of a unique advantage by staying continuously in one environment, which means we don't have to convert data from GIS to CAD and vice versa, since everything is always CAD data. Our GIS techs and engineers can speak the same technical language, which I believe promotes a greater sense of team and collaboration. Our GIS techs also support our engineers from time to time with software troubleshooting, since they are become experts with the software. And our GIS techs, in some cases, are promoted to engineering, and in those cases, there's no software learning curve for them, since they're already using CAD. And finally, since we're using Map 3D, which supports real-world coordinates, our engineers can actually do their designs in the real-world coordinates. They can go out with a Trimble GPS, they can walk their proposed routes, and they can bring them into CAD and be right, find it on the map exactly where they were. So this is kind of our pre-FME GIS setup. We have, as you can see, AutoCAD Map 3D linking with Microsoft SQL Server for the attributes, as I mentioned, and Oasis FM, which helps manage this connection by providing a palette inside of AutoCAD for automatic linking of data to AutoCAD DWG objects. So where does FME come in? So with FME, we have the desktop version, which was explained earlier, is used to set up workspaces for automating data translation. And so primarily, originally, our FME was used, the reason we got it was to be able to take our CAD data and put it into Microsoft SQL Spatial, so that we could leverage the spatial abilities within inside of Microsoft SQL. Since we already had the SQL Server, it was a natural fit for us to kind of use that as our enterprise GIS solution. Now, with AutoCAD Map 3D, you can actually move stuff in SQL Spatial without FME, but it is a cumbersome process, as some of you may know. It's a two-step process. You have to first convert your CAD DWG data to a data type such as a shape file or an SDF file, and then from there, you then have to bulk copy it into the database. That process, could take anywhere from, a couple hours to sometimes even a full day, depending on how much data you had. And with the amount of data we had, it was not sustainable for us if we wanted to do nightly updates, and which we really wanted to have data that was current, to have it updated at least once a day. So we looked at FME to do that. We built a workspace that automated that process. It runs in less than an hour. It can be run at night when nobody is around, so it eliminates any human intervention as well as interruptions. And we can also get the benefit of having that data always being current. So that is how FME has primarily been used. But we also find, in addition to the nightly conversions, FME is also useful for many other things that we did not expect. For example, there are many projects where we need to take our data and display it in Google Earth, and FME has tools to quickly convert our either CAD data or data from our SQL Server to a KML file. We also have a mobile solution where we're using AutoCAD WS to go out in the field, and our drawings as they exist today are a little bit too large for that program. And so we were able to use FME to strip out just the layers that were critical for our field workers to bring those down to size, and we're able to automate that process with FME. And in addition, AutoCAD drawings, we found that FME was a useful tool for cleaning up those CAD drawings. If we wanted to, for example, make sure everything was on the right layer, that our CAD standards were being adhered to, that we didn't have anything going on wrong layers or extra layers that weren't supposed to be in there. FME is also useful for detecting those types of inconsistencies. And finally, the ability to do ad hoc GIS queries. And I'll talk a little more about that later. So in terms of the advantages of having our data in spatial data inside of SQL Server, one of the things that allows us to do is to have a centralized location to serve up our web-based maps, which currently we're using Map Guide to do that. So rather than having SDF files or shape files, it's all looking at our SQL Server in one location, which makes it very easy to manage. Also, it allows all of our data to be in an FDO-ready format. So if there's any ever situation where we need to do any type of GIS function, such as buffering, overlaying, or thematic maps, we're able to use that functionality in Map3D with our data that's already ready in a format to be used in that way. And finally, the ability to do spatial queries with this inside of Microsoft SQL Server. Since we do a lot of SSRS reports, which is basically web-based reports for SQL data, this came in very handy to be able to do the spatial overlays to allow end users without any GIS knowledge or experience to do spatial queries without even realize they're doing that. And I'll show you that here in a little bit. So actually, I'll show you right now, spatially driven SQL reports. So here's an example of where a spatial query might be needed. You can see these red boundaries here represent our customer serving areas. And from time to time, my engineering manager will want to get a report to know how much copper, sorted by the type, the size, and the gauge, exists in one of these serving areas. For example, if we wanted to do a copper replacement project. So, in the past, we go into AutoCAD and we do a simple select by polygon. We'd pull so we'd be able to get all the copper that was affected, and then we would, pull it into a spreadsheet, sort the data, and eventually come up with a report. That could take one of my GIS techs, maybe, 30 minutes, an hour to do. But now that our data is inside of SQL Spatial, this right here is an SSRS report. It's Microsoft's reporting report writer. I think of it similar to Crystal Reports. You can design your reports, and they all are available online. And this is one I developed for my boss, the engineering manager. And it has a little drop down here where you can click on the drop down, which represents the polygons I was showing you earlier. And it'll come back, it'll do an overlay and come back with all the copper within inside of that polygon and automatically sort it by type, size, and gauge. So very quickly, rather than having to wait an hour to get the data back, my engineering manager from his desk can do without having to have an open CAD, can do a simple spatial query using this report. It's found that very useful. This shows you what's going on behind the scenes inside of SQL, inside of Microsoft SQL Server. This is a simple select statement with a st-intersect overlay, and you can actually see the results of that query inside of Microsoft SQL Server Studio. Similar example here, same type of polygons. For us at a telephone company, a lot of times, we have these we create these new boundaries because we maybe have a proposed location, such as this one here, where we want to build a new site to serve these customers which maybe currently are served from a neighboring site. And so we want to get some information. We don't have anything in our databases about them yet, because everything in our databases shows them being served by this neighboring location, but we know the geography of what this new site is going to serve. And so these little dots here represent customer locations. And so, sometimes we want to do an overlay to find out how many customers are in that new geographic boundary that we're going to serve, which is very useful for us to know, because then we know exactly what type of equipment we need. If there's DSL customers, how many DSL cards we're going to need to buy to get the appropriate equipment to serve the number of customers and types of customers that are going to be in that area. So again, we have the same type of report, overlaying the polygon. Very quickly we're able to see which customers, and you can see we have 20 POTS customers, that's just regular telephone service, 25 DSL customers, 0 specials, and 45 totals. So it gives us a real quick way to plan for the future. A very effective planning tool, which can be done by our engineers without having ever to open CAD. So finally, I want to talk about FME as a GIS toolbox. For those of you who are Esri users, which some of you may be, I know with Esri is very rich, with its GIS analysis tools, overlaying, buffering, intersecting, and just a variety of things that I haven't used all of it, but somewhat aware of it. And FME actually has a lot of those tools as well. CAD has, Map 3D has a few. You can do some simple buffers and overlays, but not as many as FME has, and FME is a lot more flexible in that. So I like to think of being able to maintain our data in AutoCAD, which is the perfect tool for that because it's very easy to manipulate the data with all the CAD tools available. We store our data in SQL, and then we use FME to analyze it. So let me show you an example of that in a real-world scenario. We were doing grant applications looking for funding for some of our broadband projects. This is a state grant that we were looking for, and as part of the application process, they required maps as well as GIS data, and so our regulatory department turned to us to provide that for them, and a lot of this required spatial type queries. And so here's a couple examples of some FME workspaces. One of the requirements, we had to provide census block data, and so to bring that census block data, when we got it from the Census Bureau, it's for a very large area, and to bring it into AutoCAD, sometimes the performance suffered because it's such a large data set. Well, FME is perfect for being able to really narrow that down to just the census blocks that were in our area. And so what we have here is we have our boundaries. This is the data source of our boundaries, and this is the data source of the census data. We're just doing a simple spatial filter, and out comes the census blocks that are just inside of our area. Part of the requirement too was to do some buffering of our project areas to see what would be affected, and FME is great for that. And you could take our project area, do a buffer, and that's how we used FME to kind of create those buffers. We could put them inside of eventually store them inside of SQL Server to do later analysis with them. We also needed to overlay our census block information zip code on subscribers. We needed to append to our subscriber data what census block each subscriber was in, as well as what zip code each subscriber was in. So in this case, we have census blocks and our subscribers coming in, and it's all the subscriber information with what census block they're in. Same thing with zip codes. So some overlay analysis to provide appending of the overlay attributes onto the source attributes or source data. And this was kind of the big one. With these projects that we were proposing, they wanted to know the impact it would have on broadband availability. Well, as you may be aware, broadband availability is a distance-based question. It's how far is the subscriber from the serving node. So we went and researched the manufacturer specs of the technology we were putting in and determined that kind of our best guess, 0 to 2,500 feet, we would be able to, any customer within 0 to 2,500 feet from the node, we would be able to provide 50 megs, 2,500 to 5,000, 30 megs, and as you get further out, you can see it drops until eventually it's not available. So how do we provide this for the regulatory department? Well, it's definitely a GIS question of overlaying these bands on our subscriber data. We used to be able to do this in AutoCAD Map 3D. We still do that today, but it took a long time, 2.5 hours to do that. Whereas with the GIS tools in FME, we were able to reduce that to about 5 minutes. And I'll show you exactly what I mean here. So we'll do a quick live demo. So this is inside of CAD, and these green areas are the different project areas that we were proposing. And this other color is all the subscribers. So what we would have to do in CAD is we come in here, we could do a quick buffer. We'll select these project areas. And so to say for that first one, we wanted to go from 2,500 feet to 5,000 feet. So on the short end, 2,500 gives us that buffer, and then do that again. And so what we need is the band that's in between these two buffers. So we want to eliminate this middle area, basically create a donut. So we'll do an overlay, second buffer as a source, the first buffer as the overlay. We'll do an erase, and we end up with a donut or a band that looks like that. That represents one of the bands that we need to do. And then finally, we can do then an overlay to see how these impact, which of these, little dots, which represent subscribers, fall into the area. So AutoCAD Map 3D has this nice overlay tool, and we use a subscriber as a source, that little donut as an overlay. And it takes, a little bit of time to run that analysis. There it goes. And then we end up with this new layer of customers that are just inside of those boundaries. So then we can come in here, we have a report, do a select all, and export that to a CSV file or something like that. So that's how we used to do it in AutoCAD. You can see it's not too bad. It's it's functional, and we can do that. But imagine doing that for as I mentioned, I think we had 7 or 8 different bands, and we kind of had to redo that. Throw on top of that, my boss kept changing his mind about the distances that we had for each of these bands, and so having to redo that several times is very time consuming. So FME was able to save us a lot of time with that. So what we have going on here is the same data, those project boundaries. This is the project boundary coming in. We have the first buffer, which is the inside buffer and the outside buffer. We're doing an overlay clipping here, and then taking the results of that and using that as a spatial filter on our subscriber data coming in. So it's basically exactly the same process, just doing it inside of FME, and that will give us our result. Now normally this would maybe push to a shapefile or whatever. We have it going to an Excel spreadsheet. But I have sending it to what they call an inspector, which allows you to kind of see the results. And so I'll show that what happens. So this buffer here, we're going to start from 2,500 feet to 5,000 feet. So that same buffer we just did. I'm going to go ahead and run this. And you'll see that whole thing I just took 5 minutes to do was able to accomplish in seconds. And you can see the results here, the bands and the subscribers. And I also mentioned that it spit out a spreadsheet. While I wait for that, I'll go ahead and, so then if we want to do the next buffer, we can, maybe this one was from 5,000 feet, to 7,500 feet, the next band. All I have to do is change these parameters. Oh, there's a spreadsheet. Come back to that. 7,500 feet. So it's really easy to change the parameters and just rerun it and get a result from the next set. Of course, it's going to fail on me because I have the spreadsheet open, but here's the spreadsheet. You can see that there was a total of 1,350 customers, and we could expand this to include other attributes, customer information, which I didn't include in the demo, but normally that's what we would have. Let me close that, run this again, and this time the bands are a little bigger, as you can see, and you can see the results from there. And then I could open up the spreadsheet again and get the results of that query. So that's pretty much the tool we used, and it was very useful. And for this project, it saved us a lot of hours on this type of analysis that we were having to do. A couple screenshots of what we were able to accomplish. Here's our spreadsheet. This time, we came up with 1352 customers. So what was the result? We were able to meet all the GIS requirements to support these grants without having to go to a third party. To do that, we did all in-house. 4 of the 5 grants we applied for, we were able to get approved, which resulted in a proven ROI for our GIS investment. We actually had just bought FME that same year that we started this application process, and so I was able to let them know how much time it saved us. And I really don't think without FME we would have been able to provide the data and the time frame that was required. So it definitely gave us a little more credibility in terms of what GIS is able to do, and also the technology that we were investing in. So with that, I guess I don't know if there's any questions, but that concludes it.